Something new. Stop, drop, shut 'em down, open up shop. Oh, no, that's how rock pilots roll.
Yeah, opening up the chapter with some Ja, but we all know what's real, and it's DMX, baby. So here we go. Let's get started. Last video lesson of this chapter today, we're going to talk about combining like terms and what's called the distributive property. So let's jump right into it. All right, so looking at this, we have expressions that contain numbers, just plain old numbers called constants and variables. So how do I simplify things that have variables? Take, for example, the one we have here, which is 2x minus 5 plus 3x. So what I have here are two terms, 2x and 3x, that both contain a variable, and then minus 5 that does not. So how the heck do I combine these? How do I simplify this expression? Okay, some of you might be familiar with this, but think about 2x. What does that mean, 2x? Well, it literally means that I have two x's. Okay, and then you can think minus 5. Well, what's minus 5? Well, it's really saying I have 5 negative 1's combined together. And then over here, 3x, I have 1, 2, 3 x's. So if we were to look at this and just imagine these being maybe like little tiles, you may have worked with algebra tiles in the past. Let me put circles around these x's, all right? If you look at this expression, how many x's do we have in total? Well, we have the 2 over here, but we also have the 3. So in total, what I have are 5 x's combined together. And then if you look at the negative 1's, well, I just still have 5 negative 1's. We don't have any other negative 1's in the problem. So what I get is keep those negative 1's to get me negative 5. So what ends up happening here is I'm able to simplify this expression by just combining all the x's. And that's what we're going to be doing today. So let's take a look at another example. So here I have 3x minus 2 minus 5x plus 6. Okay, so I have two terms that have a variable of x, and then I have minus 2 and plus 6. Okay, so imagine again, just like we talked about in the last example, that with these x's I have 1, 2, 3 x's. All right. Now the difficulty is now notice I have a negative 5x, so I have to pay attention to the negative sign in front. So imagine this now as negative x, negative x, negative x, negative x, and negative x. Same thing can be said with the numbers. So the numbers I have negative 2, which can be formed by taking negative 1 and negative 1. So notice I'm just looking at these in terms of whole numbers. And then my 6 I have, not instead of negative 1, but I have plus 1, plus 1, plus 1, plus 1. That's 4, 5, and 6. Now let's look at what we have and let's see how we can combine things. So notice here how I have a positive x and a negative x. Well, what happens when you add a positive and a negative of something? They cancel out. So these two end up canceling each other out. These two end up canceling each other out. And we also have another set that ends up canceling each other out. So in terms of the x's, how many are left over? Well, we're left over with only 2 negative x's. So that's going to give me negative 2x. We can do the same thing with the 1's. I got a 1 that cancels out here, a 1 that cancels out here. Positive and negative are going to cancel out. And how many x's am I left with? Oh, sorry, how many 1's am I left with? Well, I'm left with plus 4. And this gives me my expression simplified as negative 2x plus 4. So hopefully you guys are starting to see kind of what's happening here. 3 and negative 5 combine to form negative 2. Well, how do I get from 3 to negative 5 to negative 2? Well, all I did really was take 3 plus negative 5, adding real numbers like we did in section 2.2. Same thing here, negative 2 plus 6, well, that gave me positive 4. All right, so what we're doing here is we're just combining things that are similar, things with the same variable and numbers by themselves. Notice I can't combine numbers with variables. I cannot combine 5x and 6 or 3x and 2. You can only combine things that are alike. Okay, so let's take a look at this next example. I have 6c plus 3d minus 4c minus d. All right, so we're going to try and do this one without doing the process we did in the previous example. So again, what you're going to do is try and combine things that are alike. So what do I have that are alike? Well, I have 6c. I have negative 4c. So if we can combine those, 6c and negative 4c, what am I going to get? Well, think, what you're going to do is just take 6 plus negative 4, and that's going to give me 2, and then I'm just going to keep the variable c. What else do we have in common? Well, we have 3d, positive 3d, and negative d. Now, negative d, what is the, well, shoot, okay, well, there's no number there. What the heck do I do? Well, remember, when there's no number in front of the variable, there technically is, and it's 1. So this one really says negative 1d. So again, combine 3 plus negative 1, that's going to give me plus 2d. So I get 2c and not, well, I mean 2d. That is the question. Notice C and D, a little cat dog action. Gotcha. Okay, so taking a look here, combining like terms is what we first talked about and what we did in those last couple examples. So when I combine like terms, I am going to add the terms that have exactly the same variables. So that means you are going to add numbers, that's not a hashtag, that's a number sign, to numbers. I'm going to add variables to variables. The key thing here is that the variables must have the same exponent. That's going to be a little tricky. I may not see it in this chapter, but that's for future chapters to come. All right, so let's go through another example, but first, a little video for you.
And in your experience, was Sonny a good father to Julian?
Oh, yes. They make a terrific pair. They went together like lamb and tuna fish.
Lamb and tuna fish?
Maybe you like spaghetti and meatball? You more comfortable with that analogy?
Yes, considering we're in America. I mean, if you don't like spaghetti and meatballs, why don't you get the hell out?
Hey, listen, I'll come down there and give you a crew cut, mister.
Let's see your clippers.
Not my problem. Your father was sick.
Stop yelling at me!
All right, that's too funny. A little Big Daddy action there. But here we go. We have lamb and ham. Oh, shoot, I thought it was tuna fish. I should have put a T in there. Oh, well, we got lamb and tuna fish, or spaghetti and meatball if you're better with that analogy. But anyways, here we go. We're going to look for things that have the same variable, and again, numbers to numbers. So let's take a look. I'm just going to circle things that are alike. So first one I see is 5L. So I'm going to look for other L's. Well, I have negative 8L, and that's about it. So first thing I want to point out here is make sure you pay attention to the negatives. Every number is not going to be positive. So when you see a negative attached or in front of a number, you have to know that it goes with it. So I have 5 plus negative 8. Well, what's 5 and negative 8? That's going to give me negative 3L. I'll draw my L like that, so you know it's an L, not a 1. Okay, next one I have H. Okay, 12H. Ooh, I see 3H over here, and notice it's positive. Sorry, I didn't get to circle the positives there. So what's 12 plus 3? Well, that's going to give me plus 15H. Next one, I have minus 30. So this one's just a plain old number. Notice I got the negative with it, and then I have positive 7. So what's negative 30 plus 7? That is going to give you negative 23. So combining like terms, I notice I circled every term up there. I get negative 3L plus 15H minus 23. Okay, so what we're doing here is combining like terms. All right, let's go through some more examples. I'm going to go through these a little quicker. Okay, so notice I'm not going to really circle things here, but I'll just show you we're going to look for things that have the same variable or numbers with numbers. So the first one I have 5R and 12R. I notice that both those are R, so 5 plus 12, both are positive. It's going to give me 17R. Next one I have negative 8 and negative 20. Careful here, notice they're both negative. So what's negative 8? Well, you can look at this as plus negative 20. Always think addition. You're going to get negative 28. You can write that as positive, but remember we can also label as subtraction. So combining like terms, I get 17R minus 28. Next one here, I get negative 3W plus 10 plus 3W minus 3. So I'm going to take the W's, negative 3W plus 12W. So I got negative 3 plus 12. That's going to give me 9W. 10 plus negative 3. Okay, so we're adding negatives again here. So 10 plus negative 3. That's going to give me positive 7. So I get 9W plus 7. All right, give you guys a shot here. I want you to pause the video right now. I did the first two examples. Pause the video and give these last two a shot. Here we go. Give it a good pause, pause, pause. Okay, here are the solutions. Let's see what you get. The first one should have been a little easy, right? I have here x and y. So what I did is I looked 8x. Okay, I found the other 6x. That's 14x. Negative 12y plus 8, get negative 4y. Notice there's just a 4 left over. Can I combine that with anything? Well, there's no other numbers, so no. 4 just stays by itself. So I get 14x minus 4y plus 4. Next one was sassy. I wanted to challenge you guys a little bit. Okay? We're not really going to look at this too much this chapter, but in this example you have 5s. And then I have 6s to the second power. So here's the thing about like terms. When you combine like terms, they must have the same variable. So you must have s and you must have s. But they also must have the same exponent or the same power. Notice that this one, s, the first one, doesn't have a power. It technically does. It technically has a power of 1. Okay? But the 6x to the second power, that one has a different exponent. So I can't combine 5s and 6s or 3s and s. Instead, if I have 5s, I have to look for just plain old s, which I have at the end. So 5s and s give me 6s. Negative 6s to the second power, I can combine with the other s to the second power of negative 3. So here you get negative 6 plus negative 3 gives me negative 9s to the second power. The variable and power or exponent, notice, don't change. And then again, I'm left with that plus 4 at the end. So here is when they have to have the same exponent. You combine them by looking at the same variable and the same exponent. So a little twist there. All right, up next we're going to look at something called the distributive property. Before we do that, the way I'm going to kind of introduce it is through something we did last chapter by translating this phrase. So this phrase says twice the sum of a number and 2. Okay, twice the sum of a number and 2. So sum, what does that mean? That means addition. Twice, that means I'm going to multiply by 2. So what am I going to multiply by 2? Well, it says the sum of a number and 2. So this would be, call this n, I could call it x, and 2. So I'm going to take the sum, n plus 2, and I'm going to multiply that by 2. Okay. So what I get is this expression, 2 times n plus 2. Well, can I simplify this? No, the answer is no. I mean, if you think order of operations, when I look inside the parentheses, I have n plus 2. This cannot be simplified because I don't know what n is, and I cannot, like we talked about, combine n and 2 because they're not like terms. So how do I simplify something like this if I don't know what n is? To show you, I'm going to give you some examples. So let's say for this example that n equals 4. Okay? So over here on the left, let me show you. So if I take 2 times 4 plus 2, let's see what I get. Okay, so order of operations tells me I'm going to start inside the parentheses. 4 plus 2, that's going to give me 6. Multiply that by 2. 2 times 6 gives me 12. So here I get 12. Okay? Now, let's take a look at another way to do this. 2 times 4 plus 2. So you got to think of what's actually going on here. I'm taking 2 and multiplying it by 4 plus 2. This is the same thing as saying that I'm taking 2 and I'm multiplying it by the 4 and I'm multiplying it by the 2. So what I can do is take 2, multiply it by the 4, and also take this same 2 and multiply it by the 2. So all I did was take the 2 and multiply it by 4 and by 2. And let's see what we get. Order of operations says I'm going to do multiplication first, so 2 times 4 is going to be 8. And then add to that, 2 times 2 is 4. What's 8 plus 4? 12. So what do you notice from here to here? That they're the same thing. But why is this important to point out? It's important to point out because when I throw variables in here like n, like x, or whatever it may be, plus a number, I cannot add those things together. So what we can use is instead of adding together and going this route, is we can use the idea of multiplication. I can take and multiply the number on the outside by each number on the inside. Okay, what I'm going to do, if you see what I did here and what I drew, is I'm going to distribute the number outside to each number inside. Distribute simply means to multiply, and this is what's called the distributive property. Okay, you're going to take the number outside, distribute it, which means to multiply, to everything that's inside those parentheses. Okay, so let's go through some examples. Let's simplify. So I have 3h plus 6. Again, I can't combine these. They're not like terms. Okay, they don't have the same variable, same power. So what do? I'm going to take this and distribute it. Now, where's the 4? The 4 is on the right side here. So when I distribute this, I'm going to start by distributing it to the left first. The reason why I'm going to the left first, going all the way to 3h, is just when I write this down, it's going to be written from left to right. Okay? And that's going to be easy, and it's going to take care of all the signs. So 4 times 3h is going to give me 12h. Then I'm going to take 4 and distribute that to the 6. By multiplying 4 times 6, that's going to give me plus 24. And that's simplified. Okay? I can't add those two things together, but now this is simplified. I got rid of those parentheses and multiplied those things together. Next one. 3, parentheses 5x plus 2, plus 2x plus 4. So again, I see the 3 in the parentheses. This is going to automatically be a sign that I need to distribute. So I'm going to take the 3 and distribute to the 5x and the 2. The 3 times the 5x is going to give me 15x, plus 3 times 2 is going to give me 6. Then I'm going to keep everything else I haven't touched yet, which is a 2x plus 4. And now you have a problem just like we did before. Okay, I have 15x and 2x. Those both have x to the power of 1. So 15x plus 2x, that's going to give me 17x. And then I have 6 and 4. Combining those together, that's going to give me plus 10. Okay? So again, distributed, and then we can just use the same idea as we started off with by combining like terms. All right, next one. Next one, be aware of, pay attention to. I notice, yes, parentheses. I know I'm going to have to distribute. Boom, boom. But the question is, what am I distributing here? Notice here, this is not just 3. This is negative 3. And this is the biggest mistake I see with the distributive property, is people forgetting the negative sign. So you have to pay attention here. So instead of distributing a 3, I'm actually distributing a negative 3. So let's see what happens. I'm going to get 8. And then here I have negative 3 times 2m. So when I multiply these, I'm just going to multiply the numbers. Negative 3 times 2, that's going to give me negative 6m. Then I have negative 3 times negative 5. So that's going to give me positive 15, because a negative times a negative, same sign, always means they're positive. So what ended up happening here? Well, this was positive and now it's negative. And this was negative, now it's positive. So it ends up flipping the sign. If you didn't pay attention to the 3, you would actually get an incorrect answer. And now lastly, again, what I can do is combine like terms. So I have 8 and 15. They're both positive, so 8 plus 15 is going to give me 23 minus 6m. And there's my answer. So key thing here, make sure you pay attention to any negative signs. All right, here we go. I want you to pause the video here. Last 4 examples for this video. Pause the video, give you the shot. I'll give you a second or two before the solutions actually show up. So here we go. Give it a pause. Okie dokie, let's see what you get. First one, 3x plus 2 times 4x minus 8. I see the plus 2 that I'm going to have to distribute. So 2 times 4 would be 8. 2 times negative 8 would give me negative 16. Combine the 3x and the 8x, give me 11x. Boom. Donezo. Next one, 4 minus 5 times 3w minus 5. So notice the negative 5 here, not positive. So I got to distribute the negative 5. That's going to give me 4 minus 15w plus 25, because negative times a negative, positive, negative times a positive is a negative. Combining the 4 and the 25, both are positive. I get 29 minus 15w. Okay, the third example, we'll ask you through in a fraction there for you. So you're distributing 3/4, which is perfectly fine. So I get 3/4 times 8r minus 3. I'm going to distribute the 3/4 to the 8r and the 3. I wrote it out here for you. So remember, when you distribute a fraction to a whole number, especially with the variable, kept the variable on the outside, but I put 8 over 1 instead. Wrote that whole number as a fraction. So then multiplying that, I got 24 over 4. Multiplied top, 3 times 8 is 24. 4 times 1 is 4. Got that. This one, minus, kept the negative sign. 3/4 times 3 over 1. Did the same thing, put the whole number over the fraction. Technically, I'd be an integer, but don't tell anybody I said whole number. And I get 3 times 3, which is 9, and 4 times 1, which is 4. This one I could simplify. 24 over 4, I got 6 over 1, which is just 6. So 6r minus 9 over 4. In the last example, we had to use a calculator. You get 12.5 times 2v minus 4. So you have to distribute 12.5. Expect you to use a calculator here. 12.5 times 2 is 25, and 12.5 times negative 4, going to have the negative, but that's going to give me 50. All right, and I will leave you with a little bit more, Big Daddy. Enjoy. We'll see you in class. Good luck on the practice.
Koufax is a good egg. He was nice to that kid. But he fights like a girl. You like that? I'm right here. Miss, what are you going to do about it?
Enjoy. See you, kids.